Now let us take the reverse process. Okay, one more example. Okay, example, let x of t has x of j omega as the Fourier transform, and I say let x of t x of j omega be CTFT pair. Okay, find the inverse CTFT of Okay, so we'll take first example, x1 of j omega, which is equal to x of j 3 omega minus 4. Okay, we want to find the inverse Fourier transform of this signal, means we want to find x1 of t. Okay, yes, so question is, which signal x1 of t will have x1 of j omega, which is equal to x of j times 3 omega minus 4 as the Fourier transform. Okay, again we have to do the similar rule what we have done for previous two examples, but in frequency domain. So let us define a new Fourier transform as x11 of j omega, which is just x of j omega minus 4. Okay, so this is just shifted version of Fourier transform. So this fellow will have what as the signal here? This fellow will have x11 of t, which is equal to how much? Because this is shifting in frequency domain. In time domain, what should we do? We should multiply with e power j 4t x of t, correct? So if you multiply the signal x of t with e power j 4t, you will get x of j omega minus 4 as the Fourier transform, and let we call that to be x11 of j omega. Okay, right, now let us define one more signal, x21 of j omega, which is equal to x11 of j3 omega. Okay, x11 of j3 omega. So this should be equal to how much? That okay, so we will come to that. So this should be it is x11 of j3 omega. Clearly this is looking like shifting in which domain? Frequency domain, but the scaling factor is missing, so let us use that scaling factor. So that should be equal to, we can write it as 1 by 3 times 1 by 1 by 3 x11 of j omega whole divided by 1 by 3. Can you write like this here? x11 of j3 omega can be written as 1 by 3 times 1 by 1 by 3 x11 of j omega by 3. Okay, why did we write like this? Why? Because we know that 1 by mod a x11 of j omega by a will have the signal, the corresponding signal which has this as the Fourier transform. Okay, so the corresponding signal would be how much? That should be x12 of t, which is equal to how much now? 1 by 3 times this is 1 by a x11 of j omega by a. So which signal will have that as a Fourier transform? x11 of at. A is how much? 1 by 3. So you will get x11 of t by 3. So 1 by 3 times x11 of j3t will have x11 of j3 omega as the Fourier transform. But what is x11 of j3 omega here? That is nothing but x of j3 omega minus 4, and that is same as how much? That is same as our x11 x1 of j omega. Okay, so let us substitute in the time domain. So this should be equal to 1 by 3 times x11 of t is this. x11 of t by 3 means wherever there is t, replace with t by 3. So that should be e power j 4 times t by 3 multiplied with, here also we have t. So that fellow will be x of t by 3. Okay, so 1 by 3 times e power j 4t by 3 multiplied with x of t by 3 will have x of j 3 omega minus 4 as the Fourier transform. Okay, this is the reverse process of the previous example. Okay, again just for understanding we'll take one more example. Second one, let us take x2 of j omega to be equal to, let us take x2 of j omega to be equal to x of j times minus omega by 2 minus 3. Okay, we'll take this x2 of j omega to be equal to x of j minus omega by 2 minus 3. Okay, so again we want to find what the signal x2 of t, which will have x2 of j omega as the Fourier transform, which is equal to capital X of j minus omega by 2 minus 3 as the Fourier transform. Okay, so as usual we have to use divide and conquer. So what is that? First you have to shift, then time scale, then time reversal. So we all the three we have to do step by step. So first let us define the first function, which is x21 of j omega, which is equal to x2 of j omega minus 3. Correct. So this fellow definitely will have what as Fourier transform. Which signal will have this as a Fourier transform? It is x21 of t. What is the property? Frequency shifting, and hence you have to, in time domain, you have to multiply with e power j3t with x of t. So this fellow will have x2 of j omega minus 3 as the Fourier transform. But let's move on. So we define new signal x22 of j omega to be how much? What is your expectation? x21 of what? We want minus sign, you will see later. We want omega by 2. So we will replace omega with omega by 2 in x21 of j omega. Okay, so before yes, so this would be again written as 2 times, because it is frequency time scaling property, we have to write in a proper way. So we want to what? 2 times 1 by 2 x21 of j omega by 2. Correct. So we can write this function in this form. Correct. Why? We want like 1 by mod a x of j omega by a. Okay, so definitely we can use the time scaling property if we write in this form. Okay, but this should be equal to how much here? That is equal to x2 of j times omega by 2 minus 3. Okay, but this fellow will have, which signal will have this as the Fourier transform? That is x22 of t, right? So that is equal to which property is involved? Time scaling. So that should be 2 times this is looking like 1 by mod a x of j omega by a. What is the corresponding signal? x21 of 2t. Correct. So 2 times x21 of 2t, but x21 of t is already known, so this should be equal to 2 times e power j60. Why? Wherever there is t, you have to replace with 2t multiplied with x of 2t. So our x22 of t is 2 e power j60 x of 2t. That fellow will have what as Fourier transform? x2 of j omega by 2 minus 3. So still we are not done. We want for which signal? This one. So definitely finally we define the last signal as x23 of j omega, which is equal to x22 of minus omega. Okay, so if you x22 of omega is this, so x22 of minus omega should be equal to x2. Correct. x2 of j times, wherever there is omega, replace with minus omega by 2 minus 3. So corresponding time domain signal would be x23 of t, which is equal to x22 of minus t. Why? Time reversal in frequency domain is same as reversal in time domain. So this should be equal to, we got x2 2 of t, and in that we have to replace t with minus t. So you will get 2 times e power minus j6t multiplied with x of minus 2t. So this signal, which is equal to how much are x2 of t, correct? So this, because Fourier transform is this. Okay, oh, I missed something. Yes, so 1 second. So this is not x2, right? So we have to talk about only x here. So sorry for that mistake. Okay, so this is x2 of x of j minus omega by 2 minus 3, but this is our x2 of j omega. Okay, so in that way we get x2 of t as 2 e power minus j60 x of minus 2t. So this fellow will have x of j minus omega by 2 minus 3 as the Fourier transform. Okay, yes, so just as homework, so I will give you few more. Okay, let x of t and x of j omega form Fourier transform pair. Okay, so CTFT pair. Okay, I'll say fill in the blanks. Okay, so fill in the blanks. Okay, let's say x of t by 3 minus 1. Okay, next x of j omega by 2 plus 3. Okay, or I'll say j omega by 3 minus 3. Okay, next I will say x of minus 2t by 3 plus 4 multiplied with e power minus j 2t. Okay, so similarly I'll say e power j 3 omega x of j times 2 omega plus 4. Okay, so one more I will say e power minus jt x of t minus 1 plus e power j2t x of t plus 2. Okay, and finally one more example, e power plus j 2 omega x of j omega plus 2 plus e power minus j omega x of j, let me say 2 or 3 omega minus 1. Okay, so let us try to find out the corresponding signals or Fourier transform depending upon the problem. So all these examples will definitely help you in understanding these properties thoroughly. Till now, whatever we have seen, what properties we have seen till now: linearity, time shifting, frequency shifting, time scaling, and time reversal properties. So if you solve these problems, definitely all these properties you will be very thorough.